back to the tutorial for operating system. So this tutorial definitely helpful for whoever preparing the exams like gate UGC and so on. Today we are going to see the topic called deadlock avoidance using Bangas algorithm with example. The previous session I explained about the various ways to handle the deadlock avoidance. So let's continue today. Please kindly check the playlist when you have doubt and continuous with the classes here. So generally, before now with the Bangas algorithm, deadlock avoidance is the one where it provides the dynamic algorithm, support and provide the dynamic algorithm to avoid the deadlock completely. Moreover, it will examine the resources and support the maximum resources for allocation. So Bangas algorithm. So Bangas is the one used majorly in the banking system to avoid deadlock. Moreover, this algorithm helps to identify whether a loan will be given or not like banking. And moreover, this algorithm is used to test for safely simulating the allocation for determining the maximum amount available for all resources. And it also checks for all the possible activities before determining whether allocation should be continued or not. So moreover, you have to remember 2 points already discussed you. That is, if a system in safe state or unsafe. If a system in safe state, that we can say there is no deadlock. If at a system in unsafe state, there will be a possibility of deadlock occur. This is for Bangas algorithm. And moreover, before calculating here, let's take the Bangas algorithm. You can solve this one. So simple and easy. So here now the formula for need of I is equal to maximum of I minus allocation. Let's consider I have a table with the process called P0, P1, P2, P3, P4, and I have allocation of resources like APC and maximum APC by default. So here P0 having the resources like 0 and 0, P1 200, P2 302, and P3 211, and P4 002. Similarly, maximum. So maximum given here 7. This is for A is 7, P for 5, and C is for 3. Subsequently, for P1 322, and P2 902, and P3 222, and P4 4333. Okay, this one I have it. Now I can see the need. So very simple and easy. So now I can see the current need of the every resource. Very simple. If you want to find the need, what you can means we can do maximum minus allocation. So when maximum minus allocation, then let's go use the pencil here. So maximum minus allocation is the maximum minus allocation is the formula for need. So first for P0, sorry, not P1, this is a P0, this is P0, this is P1, sorry, P1, this is P2, this is P3, this is P4. By mistake written, let's put here. Okay, so here P0 that is A 7 minus 0 7, and similarly B 5 minus 1 4, and C 3 minus 0 3, and similarly P1 3 minus 2 1, and maximum minus allocation formula we are using. Then 2 minus 0 2, and 2 minus 0 2. Similarly for P2 what we will get 9 minus 3 6, and 0 minus 0 0, and here also 2 minus 2 0. Subsequently for P3 we will get 0 and 1, and P4 will get 4 3 1. So this amount we can calculate the need. Need is equal to maximize allocation. Now and let's assume that for this table the process we have total number, that is A is equal to 10, B is equal to 5, and C is equal to 7. The total resource we having. Now total allocation. How do you collect the total allocation means total minus allocation. Okay, that means the for resource A, what is the total allocation? 2 plus 3 plus 2 7, and B 1 plus 1 2. Similarly C 2 plus 1 plus 1 2 5. So when you go allocation, availability, current availability, how can find it means I can find the current availability after we check every process having deadlock or not. If no deadlock, I can upload with some formula. So now how can I get availability means total minus the allocation of resource A and B C. So that is 10 minus 7 3, and B 5 minus 2 3, and 7 C 7 minus 5 2. So this is the availability I am getting. Now we are going to apply the Bangas algorithm, implement and solve the deadlock condition, deadlock also, and moreover when you go for deadlock avoidance, it should be avoid the circular weight condition. Okay. So here, and before going the safety algorithm, how do you say whether the bankers are safety or not? Because safety algorithm, you should check whether or not a system in a safe state or follow the safe sequence of bankers algorithm. There are two vectors, work and finish of length will be there. So initially is equal to work is equal to available, and the important formula is need of I is equal to less than or work. Need of I is less than equal to work, finish of is equal to false. Okay. So if at all need of I less than work, what you can do means condition true, we can add work plus the allocation, otherwise not, and update the uh, table, current available table, otherwise not. So work plus allocation of if need of I less than work, otherwise it's a deadlock, will give the chance to next process. So let's go for calculation. So there will be a table, we are continuing here. Sorry, again I'm coming P0, P1, sorry, P2, this is P2, this is P3, this is P4. Now what we are going to do is we are going to find the availability now and check whether the every process having the resource proper resource and having the safe state or not. Let's start with P0 here. So P0 I'm going to start. What is the resource having? What is the need? The need is 743 and we have to compare with the availability, that is less than or equal to less than equal to value, that's 332. Not total, we have to check every one by one. So P0 having need is 743 but availability was only 332. So what we can say, no, this is in deadlock now. Okay, P0 having the deadlock, so we can give the chance to P1. So now P1, what is the need here? The P1 need is 122, so, and less than equal to 332 means yes. Now we can say the sequence start from P1. So P1, so the value is less than 332. We can say P1 is okay. P1 don't have deadlock, so we can go the formula now. Works equal to then 322 plus 200. Okay, sorry, 322 plus 200. That is what is the need here? Allocation here 200. So P1 allocates 200, we can add. So formula I told you know, if at all no deadlock, you can add work plus allocation. So 332 plus 200, it becomes 532. Now updating the value in the P1 532. This is updated current available for the P number P1. Now we can say P1 is completed without deadlock. Now chance given to P2. So P2, what is allocation need here? 600 and check whether the updated value is 6 less than equal to 532 is what? Less than or means no, condition failed. So now P2 in deadlock. Okay, so I give the chance to P3. Now P3 what is allocation here? What is P3? What is allocation? 2111. That is less than 532 means yes. It is less than 532. So I give it the chance for P3. P3 going to enter in the deadlock, enter in the safe mode, safe system. So now formula is what? 532 plus 211. Totally becomes 743. So I'm updating the value in the P2 743. So now P3 we are successfully completed. Now chance given to the process number P4. So P4 what is that one? P4 what is that one means? Check the updated value. P4 is what? The need is what? 431. P4 is what? The need is 531 less than or equal to 743. So we can check now our formula is there. Yes, condition true. P4 is condition true. Then we can go the formula works equal to 743 plus allocation is 002. So I can add this one, it becomes 753. Then I can update the value of P4, that is 755 like. Okay, then P0. So now P3 in P4 is safe state and completed. Now we give the chance to P0 and P2 simultaneously, one by one. Now P0. Now P0, what is updated value? That is 743. So is less than equal to 745 means yes. So condition true. So you can add now work plus allocation 743 745 plus 010. It become 755. Okay, at last now P0 also completed successfully, safe state. At last we give chance to P2. So P2 what is the required, what is the need? 600. 600 less than equal to 755 means yes, condition true. Now P2 also enter in the safe mode. There is no deadlock. Now we can add it, that works equal to 755 plus 302. That is the allocation here, 302. So adding the allocation, it become 1050. This is the updated one. Final value in the available is 1057. So like that we can implement the Banger's algorithm and solve the process. Okay, solve the process 1 2 3, 0, 1, 2, 3, 4, and so on. So now we can say guarantee of with the help of banker server we solve the problem. There is no deadlock occur like that. So if you have any queries or suggestions, please kindly communicate with the following social media. If you like the video, please share and comment. Thank you.